finishing up everything that we need to know for this unit / test with matrices. So it's the last thing we have to know with matrices, and it's called determinants, and then using determinants with Cramer's rule. So if a matrix is square, remember square means same row and column, then we can assign to it a number called its determinant. Now this number, this determinant, can be used to solve systems of linear equations, which we will see later. And it can also tell us if a matrix does have an inverse. So, determinants of a 2 by 2 matrix. Everybody write this down. So here we have a matrix that's a square matrix. It's a 2 by 2 square matrix. Here it is, elements A, B, C, D. Now how you're going to see them ask you to find the determinant is a couple different ways. They'll say find the determinant of A, or they'll do this what looks like absolute value signs on A, which isn't absolute values. That says in matrices, these straight lines mean find the determinant, even though they might not even say that in the instructions. If you see the straight lines, that means find the determinant. So most of the time, they will put the straight lines on the actual elements. So this straight line just says find the determinant of A, B, C, D. And the formula for finding the determinant is this simple formula. You'll take the diagonal A times D, and then subtract it to the diagonal B times C. Now if you can recall, that is part of the formula for the inverse. Just a reminder to find A inverse. We use the formula 1 over A times D minus B times C. Do you guys see where that determinant came into play? We didn't know that was the determinant till now. And then we times that. This was the inverse. We switched A and D. And then B and C were opposite signs. So this was the formula for inverse. And once again, notice right here is the same formula as the determinant. So everybody, can you tell me, thinking about this formula, and we saw there were times when something did not have an inverse, what was happening in the formula? Yeah, our determinant, which is, now we know it's the determinant, we didn't know till now, right? This is the determinant right here. The determinant came out to be 0, making it divide by 0. If we have a determinant of 0, then we can't divide by 0, therefore there's no inverse. So that's something to note, guys. If your determinant is ever 0, you cannot find the inverse, even if it's not a 2 by 2 matrix. Alright, so if I said to you, find the determinant of this, you would do 6 times 2, which is 12, minus 3 times negative 1, so minus negative 3. So that would be 12 plus 3, which is 15. Your determinant is 15. So this 2 by 2 does have a determinant, therefore it does have an inverse. Yeah, if your determinant is 0, that would be, see how in our inverse formula that would be divide by 0? So then you can't find an inverse. Okay, so right here, really what I should do is, I should get in a better habit here. I'm going to try really hard to focus on doing this. It says find the determinant. Anytime you're asked to find the determinant, you would rewrite it and say, okay, with the straight lines you would rewrite it, because that's the sign that you're finding the determinant. So now we would times, we do the formula, 0 times 3 is 0, minus negative 1 times 2, minus negative 2. So our determinant is 2. Therefore, does this matrix have an inverse? Yes, because the determinant's not 0. Does that make sense? I didn't ask you to find the inverse, I just asked you to find the determinant. And then I was just doing a besides the fact. You just do A times D minus B times C, right? Okay. Okay, so that's how you find the determinant. Super easy of a 2 by 2 matrix. Now here's the thing. If it's not a 2 by 2 matrix, it does still have to be squared. We're only going to learn how to find the determinants of square matrices. The process is a lot more intense. So start writing this kind of down. So finding the determinant of all other square matrix is a little different. First we need to understand some vocabulary before I show you how to find the determinant. So the first vocabulary word is minor. You do need to know what minor means. So minor is the determinant obtained by deleting a row and a column. So minor, once again, is basically a minor determinant. You're going to create a determinant by deleting a row and column. So let's just look at, so right here, for example, this is a notation you're going to see it in. M stands for minor. It says find the minor, and then this stands for delete row, whatever, column, whatever. So this is telling you which row and column to cross out, essentially, which columns to delete. So you're going to see my example here. This says find the minor when you delete row 1, column 1. So everybody look at my matrix over here. Picture me crossing out row 1, which would be this, wouldn't it? Picture me crossing out row 1 and crossing out column 1. What numbers are left? 2, 4, 5, 6. And do you guys see how now we have a 2 by 2 matrix? And now we can find the determinant, because it said find the determinant when deleting a row and column. So our minor, deleting row 1, column 1, would be the determinant of this. So that would be 12 minus 20. So we get negative 8. So the minor, deleting row, column 1, equals negative 8. Does everyone see? All right, let's go do another one. This says find the minor, deleting row 3, column 3. So I'm going to erase this. And now I'm going to go delete row 3, column 3. So row 3 would be this. Column 3 would be this. So then we have our determinant 2, 3, 0, 2. So then we would do 4 minus 0. Does everyone see how I did that? So this would equal 4. So I think we probably get the picture here. Let's just do last one. The minor when deleting row 1, column 2. So look, row 1, deleting column 2. So that would leave me with numbers 0, 4, negative 2, 6. So now finding the determinant, you'll do 0 times 6, which is 0, minus negative 8. So that would equal 8. So that's how you find the minor. I haven't told you how to find the determinant yet. That's just the minor. And now the word cofactor. Does everybody, before I move on to cofactor, understand how to find minors, deleting rows and columns? Okay, let's go on to the word cofactor down here. So cofactor is the constant of the deleted portion of a row and column. Basically, it's the intersection point. So, for example, let's go back to minor row 1, column 1. Let me go ahead and highlight it this time. So row 1 we deleted, column 1. Where is the constant of intersection? 2. That is what we would put first. So this is our constant. Here's the formula. So we would have a 2, and then we have to times it by negative 1 raised to the row plus column number. So this is 1 plus 1. We deleted row 1, column 1. So then 1 plus 1. This is the formula for our cofactor of this minor. So then what we would have here mathematically is 2 times negative 1 squared. Isn't negative 1 squared 1? So 1, positive 1 times 2 is just 2. That would be our cofactor, 2. Positive 2. So you should be writing down that formula. It's the constant of intersection times by negative 1 raised to the row plus column number. So I'm going to erase this while you're kind of writing that down real quick. And we'll find the cofactor. Let's find the cofactor of row 1, column 2. So I'm going to highlight row 1, column 2. What's the intersection constant? 3. Then we're going to times it by negative 1. And then look right here. 1 plus 2. Do you guys see where I'm doing that? 1 plus 2 is 3, isn't it? So then that would, our cofactor would calculate to be a negative to an odd degree is negative. Negative 1 times 3 is negative 3. So hopefully we're getting the picture here. I'm not going to re-highlight. Let's just see if we can do it. Our cofactor of 3, 3. Oh, sorry. Did I walk in the way of you taking that? So let's do cofactor 3, 3. So that'd be deleting row 3, column 3. Where's the intersection? 6 times by negative 1 to the 3 plus 3 is 6. And even, negative 1 to an even is 1. 1 times 6 is 6. So really, guys, if you think about it, the negative 1 is just creating either a positive or negative, essentially, which is what we're going to explore next. Before I even give you the formula. So we still haven't learned how to find the determinant. We're just kind of learning how to get there. Okay, so note when it comes to the cofactor sign. Sign means positive or negative. So we know that the negative is going to come from the negative 1 raised to the m plus n, where that's the deleted row and column. So right here is a sub 1, 1, column 1, row 1, column 1, right? That's how we would state it. Row 1, column 2, row 1, column 3, row 2, column 1, row 2, column 2, element 2, column 3. This is element 3, column 1, 3, column 2, and 3, column 3. Is everybody good with that? So if we think about it, we're going to be adding those up. What's 1 plus 1? 2. What's 1 plus 2? 3. What's 1 plus 3? 4. Do you guys see how I'm just adding them and putting them down? So then we have 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. 1 plus 3 is 4. And 5 and 6. So these are the negative 1s raised to the second power. Negative 1 cubed. Negative 1 to the 4th. Negative 1 to the 3rd. Negative 1 to the 4th. Negative 1 to the 5th. Negative 1 to the 4th. Negative 1 to the 5th. Negative 1 to the 6th. Do you guys see that? So what's going to happen here? Evens are going to become positive, and odds will be negative. So look, a negative squared will be positive. Negative cubed will be negative. Negative to the 4th, positive. So what's going to happen is the positives and negatives are going to create this checkerboard pattern here. Positive, negative, positive, negative, positive, negative, positive, negative, positive. So that might be one thing you want to keep in mind, and then you wouldn't even have to calculate this portion. Because you'll just know, well, that portion's going to be positive. That portion's going to be negative. But a lot of times I just use the formula. I just plug it directly in. We'll do it both ways. Now notice it's always going to start, if this is always row 1, column 1, it'll always start in the top corner with positive. And then after that, it's just a checkerboard pattern like I said. Those will be your signs. For the negative 1 to the n plus n part. Alright, now I'm just going to test your abilities real quick, and then I'll give you the formula. Find the minor, this. So what does that say to do? Delete row 2, column 3. So then we would do the determinant of 1, 0, 3, negative 2. So then you would do, to find the determinant of a 2 by 2, 1 times negative 2 is negative 2 minus 0 times 3. So our determinant is negative 2, our minor determinant. Does everyone see? Now our cofactor of that is 4 times negative 1 to the 2 plus 3, which is 5. So won't that be negative 4? Which makes sense. Look where this sat. Look. Positive, negative, positive, negative, positive. Do you guys see how the negative came into play? So just however you want to think about it for future reference. Okay, here is the formula officially. So this is literally how you find the determinant of any other square matrix. So this is just the easiest way I felt to show it. It's not as complicated as it looks. It just is the easiest way to show it. So this is find the determinant of A, find the determinant of A. So this is a square matrix. This one is a 3 by 3 matrix, but you would tackle any square matrix this same way. So notice I have elements A, B, C, D, E, F, G, H, I. This is something you might just want to take a picture of. All we do, you guys, is it's really simple actually. So take a picture that I'm going to explain because I want you looking as I explain. You are going to pick any row or column you want to be the row or column you're deleting. It really does not matter. You can choose whatever one you want. So I'm randomly choosing row 1 here. I'm going to highlight it here. Row 1. So I chose row 1 to be the deleting row. Now after that, you're going to go through and delete each column. So delete column 1. So look, if I deleted, see look, row 1, column 1, you guys see how I have that here? What you'll do is you'll find the cofactor and minor deleting row 1, column 1. So then remember this is how we did it. We delete row 1, column 1. I would highlight here. I'm not going to do that right now. But what would be left if I deleted this? E, F, H, I. So we're finding the minor times the cofactor of that. So do you guys see how I have E, F, H, I? And then how do we find the cofactor? We take the intersection constant, which is A, we times it by -1, and then since we're deleting row 1, column 1, we'll do 1 plus 1. Does everybody see? It's just the minor and cofactor of each section. So now I've got to go do the minor and cofactor of column 2. We're still doing row 1. We're going to stay consistent. So row 1, column, now 2. So imagine me highlighting this. What would be our minor? DFGI. DFGI. Our cofactor, look, if I'm deleting this, would be, the constant would be B times by -1 to the 1 plus 2, which would be 3. Then you do the minor, say we're just adding our minor and cofactors. Now look, I'm going to go do the last one, row 1, column 3. So then if I highlighted column 3 here, our minor would be DEGH. Our cofactor would be our constant of C times by -1 to the 1 plus 3, which is 4. So you're just adding up the minor and cofactors of a row, basically, of one row we're deleting. Does that kind of make sense? So then you'll have your answer. So note, you can use any row or column. I used row 1 in this example, but we could have used row 2. Did you guys see what I'm saying? Or row 3. We could have chose column 1. Does that make sense? Kind of. And then you'll just go from there. Yes. Yeah.
How is distributed?
Yes. Now you're going to choose wisely the right row or column. You'll see what I mean in a second. Okay, so here we go. Here's my first example. Write it down for yourself. It really is super easy once you've seen one example of it. It just takes a long time once again. It says find the determinant by expanding the first row. Then it says find the determinant by expanding the second row. No matter what you use, you really will get the same answer. So I'm asking you guys, we're not going to do both. We'll get the same answer. Which one do you want to do? First row or second row? Remember, you can do it to anything. So this has you do it to both, so you can see that, yes, you get the same answer no matter what you choose. I'm not going to do both because I think it's a waste of time. So I'm just asking you guys, which one would you prefer to do? Second row? Okay, so I'm going to go ahead and highlight my second row. Let's do second row just to fill wild. Okay, here we go. So highlighting this. So now we're going to start by doing row 1, column 1. So I would even write that down. We're doing row 1, column 1. Okay? Oh, let me write down here so I have room to show all the work straight across, nice and pretty. So no, we didn't do row 1. We did row 2, didn't we? Sorry, row 2, column 1. So now I'm going to cross out column 1, everybody. So what would be the minor 3, -1, 5, 6, and then we're timesing that to our cofactor, which of this would be 0 times by -1 raised to the 2 plus 1, 3. Does everybody see? Now let's move on. Plus, now we're going to do row 2, column 2 now. So now I'm going to cross out instead row 2, column 2. So our minor would be 2, -1, -2, 6. Then times by your cofactor. The intersection is 2, so times by 2 times by -1 raised to the 2 plus 2, which is 4. Then plus, now we're deleting row 2, but now column 3. So our minor is 2, 3, -2, 5. Our constant is 4 times by -1 raised to the 5th. So now we're going to just calculate that, guys. We've got to just calculate that. So now let's look. Why was choosing row 2 the best? Well, isn't 0 times anything 0? So we don't have to calculate. Look, 0 times all this stuff is 0, isn't it? So it's smart to choose zeros. It's smart to choose as any zeros you can see. So anyways, you choose the row or column with zeros in it, because then boom, that's gone. No calculations needed. Because 0 times anything 0. Now this one we do need to calculate. So this is minor, which is 2 times, so this one says determinant, so we have 12 minus 2, don't we? So So that's a parentheses. So we have a 10, and then we're timesing that by 2, aren't we? Negative 1 to the 4th is 1, so times by 2. So we get 20. So now I've calculated this portion. Now let's go on to this. So determinant 10 minus negative 6. So wouldn't that be 16? So 16 times, it looks like negative 4. So then we get our final answer, 20 minus 64 is negative 44. So the determinant is negative 44. So question for you, does this 3 by 3 matrix have an inverse? Yes, because the determinant is not 0. Cool. Questions on that? Okay, so your life is going to be so much easier if you really do choose any row or column with zeros in it, basically. Alright, so you'll see this one looks big and scary. It actually calculates quite quickly, because look at all those zeros. Now, that is if you choose wisely, it's going to calculate quickly. So right here, if the matrix has determinants at 0, then we know that there is no inverse. So this says, does this have an inverse? So you'd say, well, I'm going to check by finding the determinant. So just once again, this is why, right? We can't divide by 0. Therefore, that is why, if the determinant is 0, there's no inverse. So this was just a reminder. Okay, I'm going to erase this so I have room to show my work here. So which row would you choose wisely with the most zeros? Row or column? Column 3 is just as good as row 2. You're equally correct. Yes, I heard people say row 2 or column 3, one of the two. So it doesn't matter. Should we go with row or column? Which one do you want to do? Column? Okay, so we're going to choose to always delete column 3. So now we're going to go find the determinant. Now guys, let's think about this wisely here. To do this, don't we delete the first row? So we're going to do row 1, and then aren't we doing column 3? Now look, that would be deleting this. Now let's think about this. If I cross this out, what's going to be the constant? 0. So should I write all this down and go to all the trouble? No, because we're going to have 0. So let's just go 0. Plus, let's delete. So we're going to delete row 2, column 3. So picture me crossing out this now. What would be the constant? 0. So we're going to just write 0. Plus, let's go to this one. This one does need to be worked with, doesn't it? So I'm going to cross this out. So our determinant is 1, 2, 4, 0, 0, 3, then 2, 4, 9. Then we're going to times by our constant of the intersection point, which is 2, times by negative 1, raised to, this is the row 3, column 3, isn't it? So that would be 6. Now then we have plus, we're deleting row 4, column 3. Isn't our constant going to be 0? So the only one we have to calculate, do you guys see, is this one. Okay, so how do we find, we just saw how to do this, so what are we actually looking at here? I'm showing my work. Isn't 2 times negative 1 to the 6 just 2? So we have 2 times by 1, 2, 4, 0, 0, 3, 2, 4, 9. So how do we find the determinant of this? This straight line means find a determinant. We just did one like this. Delete a row and column again. Do the exact same thing. So which row would be the wisest to choose? Yep, so you'd say, well, I'm going to choose this one because it has the most zeros. So now we're going to do, right here, we're going to do row 1, column, no, row 2, column 1. So that would be right here, row 2, column 1. So won't the constant be 0? So we'll have 0. Then plus row 2, column 2. So our constant would be 0 again. Plus plus row 2, column 3. Looks like we do need to calculate that one. So then we'd have determinant 1, 2, 2, 4. And then we're timesing by the intersection of 3 times by negative 1 raised to the 5th. Now I've ignored the 2 so far. We can't forget, and our answer needs to be multiplied by 2. So we'll do that in just a second. So now we have negative 3 times by this is determinant. So we would do 1 times 4, which is 4, minus 2 times 2, which is 4. And then we're timesing that, so we have 0 times by negative 3, which is 0. So we have 0 plus 0 plus 0, and then we're going to times that to 2. 0 times 2 is 0. So our determinant is 0. So our answer is, if the matrix, does the matrix have an inverse? No, because the determinant equals 0. So all that work to get a determinant of 0. Okay, awesome. So as you can see, it's like not hard, but keeping things straight is what's hard. That's why I use highlights, so, you know, if you need to rewrite out problems multiple times, it might help. Okay. Another thing to note. If you're given a matrix and I say to you, find the determinant, if you wanted, you could do row operations to make it easier on yourself. If you take a matrix and do row operations, remember you're not changing the solution, therefore you're actually not changing the determinant either. So you might choose to create some zeros so that calculating your determinant is easier. So let's look at this, for example. I'm going to give myself room. Let's find the determinant. Now if you look at this, notice, look at row 1 and row 1 and row 3. We have an 8, 24, a 2, a 6, a negative 1, a 1, a negative 4, a 12. If you look at this, if I take 8 and times it by negative 3, that will cancel out with 24, won't it? If I times 2 by negative 3, won't that become negative 6? And if we add it to this row, we'll get 0. So I'm going to perform a row operation before I go about finding the determinant to make my life easier. So I'm going to say, take row 1, times it by negative 3, add it to row 3, equaling new row 3. So let's do that. And at the same time, after that, I'm going to find the determinant. Just because that will create some zeros here. Otherwise, this will take a long time. So we have, the only thing that's changing is row 3. So I'll rewrite it in 8, 2, negative 1, negative 4. 3, 5, negative 3, 11. 2, 2, 7, negative 1. Okay, here we go. Row 1 times by negative 3. Add to this row here. So negative 3 times 8 is negative 24. Negative 24 plus 24 is 0. Negative 3 times 2 is negative 6. Negative 6 plus 6 is 0. Negative 3 times negative 1 is 3. 3 plus 1 is 4. Negative 3 times negative 4 is 12. 12 plus negative 12 is 0. So now finding the determinant is going to be quicker. So now what we do, I'm going to give myself room, is say let's choose to eliminate for sure row 3. So let's go find the determinant. Let's be quick. So we are doing row 3, column 1. So we would put it in. Row 3, column 1 here. So if I was to delete, pretend like I crossed that out. I'm going to leave it on the side so we can still see it. So we have 2, negative 1, negative 4. We have 5, negative 3, 11. We have 2, 7, negative 1. Then we're timesing that too. Why did I write that down? Times by 0. So I'm going to stop. You guys see what I'm doing? Oh dear me. Sorry, I need to focus. I don't know why I wrote all that down because we're just timesing it by 0. So anyway, sorry. So we have 0 plus, now we're doing row 3, but just keeping track for my work, row 3, column 2 is 0. Plus row 3, column 3 is a necessity, isn't it? So now, crossing out that one, we actually do have 8, 2, negative 4. Read it to me. Isn't that what's being crossed out? So then 2, 2, negative 1. Then we're going to be timesing that by 4, right? The intersection point. Times by negative 1 raised to the 6. Then we'll have plus. Then we're doing row 3, column 4, which is 0. So now the only one we have to calculate is this bad boy. Now, do you guys see any row operator? Look, notice there's no 0, which is fine. You could keep going. It's just going to take a minute. Would you rather keep going, or would you rather create some zeros in here? So what would you do? Row 3 times by negative 4 adds to row 1 equaling new row 1. So then we're not changing row 2, so I'm rewriting those in. So then we'll do this times by negative 4. Negative 4 times 2 is negative 8. Negative 8 plus 8 is 0. Negative 4 times 2 is negative 8. Negative 8 plus 2 is negative 6. Negative 4 times negative 1 is 4. 4 plus negative 4 is 0. Okay. Then we have all that times by 4. Agreed? So I'm going to ignore the times by 4 for a second. Now we're going to do row 1. Now row 1, column 1 will be 0, plus row 1, column 2 would be, crossing that out, determinant 3, 11, 2, negative 1 times by 6 times by negative 1 to the 3rd. So you're right, it was negative 6. And then we have plus row 1, column 3, which is 0. Okay, and then don't forget we're timesing by 4. See, it just takes a long time. Especially when you have to keep moving back and forth. Okay, so times this, so 3 times negative 1 is negative 3 minus 22. And then we're going to take that and times it by negative 6, aren't we? So now grab a calculator if you would. Negative 25 times negative 6. So 150. What's supposed to be negative? Oh, this should have been negative 6? Yeah. Right here? Yeah. Oh, so then a negative and a negative is a positive? Yeah. So you're saying this should have been positive 6. So then it would have been negative 150. And then negative 150 times by 4. Yep, negative 600. We found the determinant. Negative 600. We're actually going to learn how to use it to end up solving. Yes, in just a second you'll see. Great question. This is where we're going to learn. Okay, so we can, it's called Cramer's Rule. Okay, write this down. It doesn't make it actually any faster necessarily. So you guys, we have learned a couple different ways to solve systems of equations. The first thing we did in the first lesson of this unit, we learned how to solve by getting it down to reduced row echelon form or row echelon form and solving by substitution. Then we learned another method, which was, does anyone remember what the next method was? Solving by inverses. That was solving by matrix inverses, if you can recall. We found the inverse and then we went through and solved it. We used the inverse to solve. Does that recall? You guys practiced that, right? Okay. And then now we're learning another way. It's called Cramer's Rule. So Cramer's Rule uses a determinant to solve, in a sense. So another way to solve a system of equations is to use Cramer's Rule involving determinants. So notice if I have a system of equations set up ax plus by equals some r and cx plus dy equals s. So notice a and c are my x variables, my coefficients in front of my x's. B and D are the coefficients in front of the y's, and then R and S are the constant coefficients, which are the solutions. So here is the formula to solve. To find, now we know, guys, think about it. If I said to you solve this system, you solve till you get an xy point, right? You'll have an xy point as your solution. Here's the formula to find x. So notice, the first thing I'm going to point out is you just find the regular old determinant of the original problem without R and S. So we would just find the determinant of A, B, C, D. That's what goes on bottom, is the regular determinant of the original. Now what goes on top is, now why do I know it's determinant? Straight lines, okay? On top what you do is, since we're solving for x, what you do is you replace column 1, which is your x column, with your R and S. So notice I've just crossed out my x's, moved R and S in the place of that, and now I still have B and D, and I'm now finding the determinant of R, B, S, D. So basically, this is how they write it, you guys. So this is the formula. It's D of x, which means the determinant replacing column x. And then it says divided by D, which means divided by the original determinant. Okay? Then right here we do the same thing. We cross out column y, replace it with R and S. So we have ACRS, we find the determinant of that, divided by the original determinant. So y is equal to dy, so this says the determinant replacing y, divided by the original determinant. So basically your first step is to find the original determinant, and then after that you'll have to find a couple other determinants. So it's not that this is any quicker, honestly, because doesn't finding the determinant take a long time sometimes. So it's just like, you know how we were learned last time, well, why would we go through and find the inverse and then solve by inverses when we could just do dang row echelon form? It's just another way to solve. It's just another way to do things. So it's just something we have to learn how to do. Okay, now we know that we can only do this as long as the determinant does not equal 0. If the determinant does equal 0, we can't find the solution. I'm thinking, if the determinant is 0, I'm feeling like that means there's no solution. Would we be dividing by 0? It can't happen. Okay, do you have that written down? Okay, let's put it into action. No? You need more time? Okay. See, it's just a lot of new stuff, and it takes a little bit of practice. Okay. Alright, so it says use, and this is how I think it will be worded on the test. Use Cramer's rule. Use the idea of inverses to solve. You know what I mean? Use reduced row echelon form. So this one says use Cramer's rule to solve a system of equations. So you'd say, okay, I need to find my solutions, which this one has 2 variables, so we're going to have some x, y solution. So now you'd say, well, x is equal to dx over d, and y is equal to dy over d. So your first step, honestly, is to go and find out what d is. So you'd say, I got to find out what d is. So d is equal to the determinant of the original without the equal sign. So that would be 2, 6, 1, 8. That's the determinant of the original. So the determinant of the original is equal to 16 minus 6, which is 10. So just a reminder, our d is 10. So I'm going to put 10 here and 10 here in our formula. Now d of x, let's hurry and calculate that. That means find the determinant if you replace x with what's equal to. So then we're going to go cross out these and replace them with -1 and 2. So we have -1 and 2, and then we still have 6 and 8. So we'll hurry and find that determinant. We have -8 minus 12. So we get -20, don't we? So now we can go, d of x was -20. -20 divided by 10 is -2. So x equals -2. So not too shabby. It actually is easier than doing even reduced row echelon form with this one, I'd say. So now let's do d of y. The determinant when you replace y, so we're going to replace it with these. So we're going to have 2, 1, -1, 2. So then we have 4 minus -1, which is 5. So then 5 divided by 10. 1/2. So y equals 1/2. So your final answer we write as an xy point, -2, 1/2. Yay! Okay, the last thing to note on this. Let's do one more. It says use Cramer's rule to solve the system. Now here's the hard thing. This system's determinant is a lot bigger, right? It's not just a 2 by 2. So let's go through and do this real quick. So our answer is x, y, z, isn't it? Or do you not really care to do this one? What do you think? Okay. So our answer is going to be x, y, z. So then we would say, okay, x is going to be dx over d. Y is going to be dy over d. And z is going to be dz over d. So your first step really is to go find out what d is. So d is equal to, here we go. So we'll do 2, -3, 4, 1, 0, 6, 3, -2, 0. So now to calculate that's determinant, you're going to pick a row and column. So a row, basically, or column to highlight. Let's go ahead and do this one, because it has 0 in it. So now row 2, I keep doing that. I always say row 1. It's just like a habit. Okay, so now to calculate this, we have row 2, and now we're going to delete column 1, but that one does matter, doesn't it? So picture yourself crossing out this. So then we would have -3, 4, -2, 0, times by 1, times by -1 to the 3. Then plus, now we're deleting row 2, column 2, so plus 0, plus row 2, column 3. So now picture yourself crossing out that one, not crossing out this dotted line. This dotted line's gone. So then we have 2, -3, 3, -2, times by 6, times by -1 to the 5th. Oh, yay. Let's calculate that bad boy. So now we have this. -3 times 0 is 0, minus -8. That's 8, and we're timesing it by -1, aren't we? So -8, and then we're going to add that to 0. Then we're going to add that to -4 minus -9. So isn't that 5? 5 times by -6, which is -30. So we have -8 plus 0 plus -30. So our D is equal to -38. So now D is -38, -38, -38. So now the nightmare comes into play when we have to, if I had more room to write, I swear it just would be way quicker because I wouldn't have to do all this. Okay, let's go find dx. Maybe we should, I don't know, split it up, and somebody else should find dy. Or do you want to just keep going together? Okay, let's do dx. dx, so that means x is gone, and we're replacing it with 1, 0, 5. So then we have a -3, then a 4, don't we? 0, then 6, and then -2, 0. Luckily, look, there's 2 zeros here, so that's going to be quick. You'd say, okay, we're going to choose that row. Isn't the one that does matter this one? Because the others are zeros. So then we have 1, -3, 5, -2, times by 6, times by -1 to the row 2, column 3. Isn't that 5? So then we have -2 minus -15. 15 minus 2 is 13 times -6. I think it is negative 78. Yeah, negative 78. So what is x? Negative 78 divided by negative 38. Do they both divide by, you'd want your answer as fractions. So if it doesn't divide evenly, you'd start dividing it by hand. What is it? What? Cool. 39 over 19. There's your x. So now let's find dy. So then once again you'd say, so dy is replacing y. Picture yourself crossing that out. So we still have 2, 1, 3. Then we have 1, 0, 5. Then we have 4, 6, 0. So then finding this is going to be a little bit of a process. See what we're doing here? This takes forever. So then we have, I don't know, this one. Okay, so then we have, crossing out this, that'd be row 2, column 1. So then we would have 1, 4, 5, 0, wouldn't we? Picture yourself crossing out this, 1, 4, 5, 0, and then we're timesing it by 1 times by negative 1 to the third, plus, then the next one that matters is the 6, because 0 won't. So then that's row 2, column 3. So picture yourself crossing out that. So that'd be 1, 2, 1, 3, 5. Then times by 6 times by negative 1 to the fifth. So let's do this. 1 times 0, 0, minus 20. So then we have times negative 1. So won't that be positive 20? So we have 20 plus 10 minus 3, 7. 7 times negative 6. So then that's negative 22. That's what dy is. Negative 22. So negative 22 divided by negative 38. So divide both of them by, the negative divided by the negative cancels out. Divide both of them by 2. 11 and 19, right? So then y is equal to, I'll write it up here, y is equal to 11 over 19. And now we'll find the determinant replacing z. Or maybe you're like, we get the picture, and I don't want you to continue. Should we just finish it off for the video? Okay. Determinant replacing z. So then that would be dz. So then we'd have our 2, our 1, our 3, our negative 3, our 0, our negative 2, then 1, 0, 5. Luckily, now in this one, we do have 2 zeros here. So the only one that matters is this. So then we would say, okay, our determinant, this is row 2, column 1. So then we have negative 3, 1, negative 2, 5. We're timesing it by 1 times by negative 1 to the third. So then that'll be negative 15 minus negative 2. So negative 13 times by negative 1. 13. So then 13 divided by negative 38 does not simplify. And so there's your z. Negative 13 over 38. So your final answer is 39/19, 11/19, and negative 13 over 38. Woohoo! No, it's not.
So I just don't understand like why it is you have to do dz over d. Because wouldn't the d's just like times well?
D of z is like you're treating this like it's like d times z. It's d of z. That doesn't. D of z makes the determinant replacing z. That's like you're going d divided by d. You're treating. Does that make sense? You're treating it like it's a variable equation, which this is just a way of stating how to do it. Great question. All right. Okay, this is the last thing. Area of a triangle. Here's the formula. Write it down.
Why?
Because. So it's just more determinants. So to find the area of a triangle, You can literally just do, so right here, if you have a triangle, guys, finding the area is filling it in. You're going to have that creates the triangle, 3 XY points. So there's the first point, A1, B1, second point, A2, B2, and third point, A3, B3. These are just XY points. So this is the formula. You'll take, it's plus or minus. The only thing the plus and minus is there for is basically you just need to make it positive. No matter what your answer is, area is positive, which makes sense, right? Area couldn't be negative. So just the plus or minus just says make whatever answer you have positive. So then you're going to take a half, and then notice all they did was take the XY point A1, B1, XY point A2, B2, A3, B3, XY, XY, XY. And then in this one, since it's 2D, our Z is just 1s all the way down. And then all you have to do is find the determinant of this, times it by a half. So, I can't say it's not hard, it's just not annoying. So we'll do one example of that. Find the area of the triangle. So what you would do is know the formula. You'd say area is equal to, we're going to do 1/2. Then we're going to find the determinant. What's the first point? -1, 4, right? Second point is, yes, or 1, 2, right? And then 3, 6. And then for these, you always put in 1. And now we've got to find the determinant. So do you want to just go straight through and find it, or make some zeros? No. So let's go ahead and do it. Do you want to should we just hurry and calculate it? Or make there be some zeros? Let's just hurry and go for it? Okay. So let's do maybe the 1s, because 1's nice and easy. So we're doing row 1, column 3. So then our determinant, row 1, column, what the freak? Yeah, row 1, column 3. So we're crossing out this. So we'd have 1, 2, 3, 6. Then we're timesing by 1. And then we're timesing by -1 to the 4th. Moving on. Plus, we're going to do row 2, column 3. So then row 2, column 3. So then we'd have -1, 4, 3, 6. We're timesing by 1. Times by -1 to the 5th. Plus, then we're doing row 3, column 3. So then picture that crossed out. So then we have -1, 4, 1, 2. Times by 1. Times by -1 to the 5th. So now we'll calculate 6 minus 6. 0. So Dunsky. -6 minus 12 in parentheses, right? -6 minus 12. Did I do that right? -18. And then we're timesing that by -1. Don't we get 18? 18 plus, let's do this one. That's -2 minus 4 in parentheses, which is -6. -6 times -1. Oh, 3 plus 3 is 6. So it's actually -1. Wait, +1. So that'd be +6. So 18 plus 6. What? Oh! I see, because it was -6 times by +1.
There we go.
-6 times, okay. -6 times 1. Plus -6, so we get 12. The area of that triangle was 12. Wow. All right. That's the end of the lesson. 10 point quick homework.
Can you go? Yeah.
Crapola! Crapola! What did I forget friends by? Brick and a half. I swear I don't remember that area coming out to be 6. 6 would be the area then, wouldn't it? Okay, it's 6. I'm glad you guys said that. It's Monday.